In this problem, we're doing a probability calculation of the chance of choosing one of each of three types of vehicles from a car lot that has 21 vehicles on it. So read that paragraph, pause the video if you like, and I want you to think of the chance of choosing an SUV, just an SUV. So what that would be is me saying how many SUVs are there, okay? This is going to be number of SUVs divided by the total number of cars, right? In other words, the chance of success divided by the total number of chances. And that's going to be, let's see, there are 11 SUVs and there are 21 cars. So if you just go onto a lot, the chance of you picking an SUV is 11 out of 21. Great. Well, the next question is, then what's the chance of picking a compact? And this is often a place where we make mistakes. The number of compact cars is 7, but the number of total cars in the lot has now dropped to 20. And likewise, if we then say, what are the chances of picking a sports car? Well, the number of sports cars is 3, and the number of cars on the lot is now down to 19. So your total chance, and don't stop the video because I have more to say about this, the total chance of doing exactly what I said above, in other words, the total chance of going SUV, then compact, then sports car is going to be this. You take 11 over 21, you multiply it by 7 over 20, and then you multiply that by 3 over 19. Okay, so let me just grab a calculator here, do a little math. See, this is going to be 11 times 7 times 3, which is 231 divided by something kind of big, 7,980. You might say, okay, well, that's not one of my choices. There's a little more going on here. It's not just the total chance of picking cars in that order. Look at what this question is really asking. It's just saying, what are the chances we're going to audit one of each of the three types of vehicles? They didn't say anything about the order that the vehicles had to be picked in. So the question is, how many ways are there to pick one of each type of vehicle? Well, let's think about that for a moment. If I have three letters, A, B, and C, how many ways are there to arrange those? Well, there's ABC, there's ACB, and then I could start with the letter B and go BAC, and I could go BCA, or I could start with the letter C and go CAB, and then CBA. So there are, if you count them up, 6 ways to make this work. In other words, I could pick an SUV, then a compact, and then a sports car like I did, or I could do SUV, then a sports car, then a compact. It's an equivalent chance of doing that if you run the numbers, right? It's just a different order of multiplication. But what it means is I have a different calculation to do. I'm going to call this the total chance of any order. In other words, I don't care what order the cars are picked in. I just want one of each. Well, that's going to be this 231 over 7,980 times 6 different ways. Okay, and if I run the numbers there, well, I can actually do this one in my head. I don't know if I can. No, I can't. 231 times 6. Don't want to risk that. That's 1,386 divided by 7,980. Okay, so that's not bad. Now, we do need to reduce the fraction a bit, so there's some simplification that needs to happen. And when you do that simplification, I'll leave that one for you to do. You're going to find that this number right here equals one of these numbers over here. Okay, once we do a little crossing out of factors on the top and bottom.